Dear students, welcome again. We are discussing various advanced plastic processing techniques. In the previous model, we discussed basic principles, process, and applications of thermoset injection molding. Now, in this module, we will be discussing the basic principle, process, and mold. Now, we can discuss the internal method of gas assisted injection molding. In this process, the molten polymer is injected into the mold until the mold is filled about 70%. First it is injected into the mold into 70% of the capacity of the mold. Then nitrogen gas is injected. From here the nitrogen gas is injected. The polymer cools and solidified as it touches the cold side of the mold, and the nitrogen gas passes along the path of least resistance, that is which is hot, mainly in the middle part of the polymer. The gas forms bubble like blow molding. It forms bubble inside the polymer and forces the polymer against the sides of the mold, and the gas holds the polymer tight against the sides of the mold until it cools. The gas is then released from the mold and the mold is open and the product is finally ejected. Now we can see the external method of molding, the gas assisted injection molding. Here the process, the sequence of this process is like this. That is, the molten polymer is injected. Here the molten polymer is injected into the mold until the mold is in full of, here the mold will be in full of polymers, and the nitrogen gas is injected under pressure between the molten polymer and the mold. This nitrogen gas forms a thin bubble between the polymer and the mold, forcing the polymer against the opposite side of the mold. So the gas holds the polymer tight against the sides of the sides of the mold, and finally it cools. Finally the gas is released from the mold and the mold is open and the molded product is ejected. Now we shall discuss the various advantages of internal and external gas assisted injection molding process. In internal gas assisted injection molding, the polymer pick up every detail in the mold. Since it is injected, the gas is injected within the mold melt, so we get the every details of the mold, and less polymer is used to make the product, typically 20 to 50% saving of the material, and products are lighter because there is a less material, and also the cost is less. Since the material is used is very less, cost is less, and the product is lighter. Usually hollow parts are structurally strong and rigid, and the shrink mark and warpage are eliminated as the gas holds the polymer firmly against the sides of the mold until it cools and solidifies. The advantages of external gas assisted injection molding is, this method of gas assisted injection molding pick up details one side. In internal, every detail of the mold is picked up, but here it picks up the details of one side only. And as usual, the shrinkage marks and warpings are eliminated. Like this, here this shrinkage and warping is eliminated due to the pressure, due to the gas we are injecting from this side, the opposite side. So we get details of one side. This side is very perfect. Now we shall discuss the applications of gas assisted injection molding. A typical product may be the handles as we seen earlier, and automobile trim and automobile instrument panels and other large sheets, structural parts with a built-in gas channel network, and TV cabinets, shower heads, plumbing fittings, and many tube-like parts. Hollow tube-like parts can be made by this gas-assisted injection molding technique. The polymers which are generally used in gas-assisted injection molding are PP, ABS, polyethylene, polycarbonate, PVC, PS, and also PC-ABS blends. So students, in this model, we discussed the process, the basic principles and process behind the gas assisted injection molding, internal and external, their advantages and their applications. So in our next class, we will be discussing the other advanced plastic processing technique in our next module. Thank you.